Welcome to the Tuva Project. Today we're going to do a deep dive into the Tuva Quality Measures Engine, which is a product that computes HEDIS measures using NCQA certified logic. Now, to really understand the Quality Measures Engine, it's helpful to understand the Tuva data model, because to get up and running with the Quality Measures Engine, it's completely analogous to how you get up and running with Tuva. So let's do a brief review of how Tuva works. So the problem we're trying to solve is the following. Imagine you have raw claims or clinical data in your platform, and you're trying to derive analytics insights from this data. So we basically want to answer questions we care about. It's impossible to answer questions using raw healthcare data, because raw healthcare data looks like this. So it's composed of esoteric codes like bill type code or revenue center code or admit type code, etc. For instance, there is in raw claims data no concept of an acute inpatient claim or of an ED encounter or of an office visit. And in order to answer even the most basic questions, we need to define concepts on top of the raw data, and we need a whole universe of these concepts. So the challenges that we have are, first of all, we need a lot of concepts to be productive doing analytics. Having a few dozen concepts gets you nowhere in terms of productivity. You need hundreds or thousands of concepts. These concepts need to be defined precisely in code. This is typically done by people who write code. And these are nuanced concepts that are not easy to define because they require deep knowledge of healthcare data, of how medicine is practiced, of how medical services are billed. And this is specialized knowledge that lives in the heads of rare individuals who are typically not the same people as the people who write code. So looking at this in more detail, if you have multiple data sources that you're trying to bring into your data platform, all raw data sources come in different formats. They have different data models. They have different field names. They have different grain. They have different data quality problems. And what you want is to union all these data sources in a single place. And in order to do that, you need a common data model that is designed to store both claims and clinical data. And once all your data is in this common data model, you can union it all together in the same place. But even if you succeed in doing this, you still only have raw data. And as we talked about a minute ago, to answer even the most basic analytics questions, we need a whole universe of high-level concepts defined on top of the raw data. So to be productive doing analytics, at the very least, on top of your data model, you're going to want to have claims service category grouper, an encounter grouper, an episode grouper. These are ideas that help you pre-process your claims into useful concepts. You also need basic atomic concepts like the concept of a patient or the concept of an encounter or the concept of a condition or a procedure, a practitioner, etc. These are core concepts that are common building blocks for doing analytics and that are often not present in a raw claims data set. And then on top of that, you need to define higher level concepts that go into data marts, like a chronic conditions mart, for example, that could house the logic for defining which patients have which chronic conditions, or a financial PMPM mart that you would use for medical economics or financial research, or a readmissions mart or ED classification, HCCs, suspecting marts, etc. These are just marts with high-level concepts that are frequently used in all kinds of analyses. So these examples give a flavor of how large the universe of concepts to build is. This is not meant to be an exhaustive list, but it gives you a flavor of how many concepts you need. These are not anyone's secret sauce analyses. These are just table stakes that we all need to start doing analytics. And for years, we've all been reinventing the wheel, redefining these concepts in isolation inside the walled gardens of our companies. This is exactly what motivated us to start the Tuva Project. So the Tuva Project is a DBT package that runs on top of a common data model, and it produces this universe of concepts organized into data marts. So the common data model that we designed to store both claims and clinical data together with the universe of data marts, all of this is the Tuva data model. Now the Tuva DBT package runs on all major cloud data warehouses, and you can use it to put all your data in the Tuva data model. So once you have all your data in the Tuva data model, then all your data sources are unioned in a common data model. Your data is clean and data quality tested because the Tuva package comes with a universe of data quality tests and cleanup pipelines that are applied to your data. Your data is organized into marts that are designed for analytics, and you have high-level concepts built on your data that are now available. So you may compute HEDIS measures using this data because now your data is clean and data quality tested. And so the Quality Measures Engine is a product that at its heart is a DBT package running on top of the Tuva data model. So if you have your data in Tuva, you can use the DBT package to compute HEDIS measures using NCQA certified logic. Now, this is a next-gen quality measures product that is designed from the ground up to run in the modern data stack. And there are three key ideas that went into the design of this product that I want to emphasize. So first of all, it has a modern implementation. Like I said, the heart of the product is a DBT package, and this gives you several key advantages. So first of all, it's truly turnkey. If your data is already in the Tuva data model, there is no implementation. You just import a DBT package and it runs automatically on top of your data. Second of all, transparency. Because you have access to the DBT package, you have full access to all source code, and the logic to compute all the measures is written in SQL inside DBT models, so you can inspect and understand all of the logic that goes into this. This runs in your environment. Again, because it's a DBT package, you're using the same tooling that are already in place, and it's just an extension of your existing pipelines of using your cloud data warehouse plus DBT. And this is fully customizable. Because you have the DBT package, you have access to all the source code, you can modify any of the existing DBT models to change the output grain, to change the output fields, to add new fields, to build new custom reporting models if you want on top of the existing models. And finally, all of this runs on all your data sources out of the box. Again, if all your data is already in the Tuva data model, the Quality Measures Engine runs automatically on all your data sources. So that's this modern implementation is the first key idea that went into the design of this product. The second big idea is having data quality and analytics built into the product at its core. So every quality measure comes with output tables with data quality flags that let you filter to individual records, find potential data missingness or problems that are impacting the calculation of a measure. And every measure comes with summary tables that allow you to see potential problems for each measure at a glance. And the third key idea that goes into the design of this product is built-in interactive documentation. So every measure comes with an interactive page that gives you an overview of the measure, an explanation of all the logic that goes into the measure. Any potential sub-measures within a measure are explained. And there's also a visual diagram that goes with every measure that explains the whole flow of data transformation used to calculate that measure. Every node in this diagram is a DBT model. It's clickable. You can expand it to see a full description of why that transformation step exists, what is the data dictionary for that node, and understand in full detail how the measure works. So I'm going to change gears for a bit here and just show you how the interactive documentation works for a measure. So this is an example of the documentation for the DSFE measure. You can see the explanation of how there's two submeasures that are associated with this measure. You can see how the measure is calculated, explained in English. You can see the main output tables that come out of this measure are explained here. And there is this interactive measure diagram that you can go to and see a full visual explanation of the data transformation flow to calculate this measure. You can see how it's broken down into meaningful sections. Like this section up here is explaining all the logic related to the enrollment requirements for the measure. There's a section down here explaining all the logic related to the exclusion criteria for the measure, etc. Any one of the nodes in this diagram is clickable. So for instance, I can go into a node and click on it and see a description of what that node is. You can see a data dictionary for that node with all the fields and the descriptions. You can see the source code for that node here, the SQL that is producing that transformation step. You can see how many direct children and parents the node has and the path to this file in the DBT project. So this interactive graph lets you fully understand and digest the logic for a measure, and it's very easy to customize this by adding new models to these existing models for any reporting purposes that you need, if you need a different grain or a different number of fields. We also have every measure has the canonical output table that gives you reporting at the person grain. There's one row for every person in your population, but then different reporting outlooks can be created off of this. For example, this other reporting table gives you the measure at the person, payer, and sub-measure grain, which is exactly what you need for NCQA certification purposes. But you could also customize this and do reporting in any grain that is of interest to you.